secant. I introduced with what is meant by tangent and what is meant by secant. Let us recap the meaning of tangent and secant. Secant means a straight line when drawn to a circle which intersects at two distinct points is called a secant. What is tangent? When a line is drawn to the circle, it touches one and only one point, it is called as tangent. Here you can see this is called, it is touching at one point, it is called as tangent. Theorems based on tangent is there. To study regarding theorem based on tangent, the next theorem what we are going to see, you should have the knowledge regarding short distance theorem. This theorem is for in 8th standard, short distance theorem. What is this short distance theorem means? See the statement I have written. The shortest distance between a point P and a line L is perpendicular from P to L. So what does it say? Let us try to understand. Now this is the line L given. Point P is outside the line, not on the line. Point P is outside the line. Okay. PA is drawn perpendicular to line L and PB is also drawn. Another point B lies on the line L and PB is joined. Okay. Now what does it say is that the perpendicular line from P to L, that is your PA is the perpendicular line from P to L, it is the shortest distance from external point. I am telling from external point P, not A and B. So from external point. What does it mean that? Let us try to see. Now, if I take this triangle as a right angle triangle, so we know we can apply the Pythagoras theorem. Okay. In right angle triangle, we know that the hypotenuse, which is the hypotenuse? The side opposite to the right angle is PB is the hypotenuse, and PA. I am taking the line from point P on line L, that is PA and PB. Compare them, which you will find is the shortest. PA is less than PB and PA is perpendicular. So that means what does it show? That PA is the shortest distance between a point P and a line L is perpendicular from P to L. Very important. This concept we are going to use in the next theorem, which we are going to see regarding the tangent and the circle. Okay. Before I go to that theorem, very important point is there. I told you that the tangent and the circle, that is the tangent touches the circle at one and only one point. Here the point P is given and that point P is called as point of contact. So in a tangent, it is a point of contact. The point which touches the circle, that point is called as point of contact. This word is very important. What does the theorem says? Let us see now the theorem regarding the tangent and the circle. What does the theorem says that? If a circle is there and tangent is drawn, then the line drawn from the center of the circle to the point of contact, that is OP, it is perpendicular to the given tangent. That is what the statement of the theorem which we are going to see. So let us see what is that theorem. What does the statement says? The tangent at any point of a circle is perpendicular to the radius. Very important, radius and perpendicular. Then tangent to the radius through the point of contact. So what is given? A tangent is given. Whenever a tangent is there, there is a point of contact, and to that point of contact from the center a radius is joined because that point is on the circle. What is radius? The line joining the center and the point on the circle. So here let us see, xy is the tangent and P is the point of contact. To this P point of contact, O is the center of the circle, and from O, OP is joined, and we have to prove OP is perpendicular to tangent xy. So what is given to us? The circle with center O is given to us. Then Another thing what is given, xy is a tangent given to us, and where is the point of contact? Xy is tangent at P, and what we have shown, OP is the radius. This much is given to us, so that we will write it down as given. So what is given? O is the center of the circle. Very important. XY is the tangent at P. That means P is the point of contact. OP is the radius. So he has asked radius and tangent. So we have to show in given which is the radius and which is the tangent. So O is the center of the circle. XY is a tangent with P at P means P is the point of contact and OP is the radius. What we have to prove? We have to prove that these two, that is the radius and the tangent, are perpendicular to each other. What is the radius? OP. What is the tangent? XY. So OP perpendicular to XY. This is what we have to prove. To prove this we need construction. You can see over here I have drawn a dotted line. What is the construction? We are going to take point Q, which is outside the circle, and it is on XY. It is not inside the circle. If it becomes inside the circle, we cannot prove this theorem. So O is inside the circle because it is the center of the circle, and Q should be outside the circle on tangent XY. So we have to write down construction. So what is the construction? What is the construction? Q is a point. Q is a point outside the circle on XY. What is your XY? Tangent. Remember that point should be on the tangent only. So it is. And where is that point if you compare with the circle? It is outside the circle. So on XY. And what you have done? You have joined OQ. So join OQ. That is what you have done. So once again, Q is a point outside the circle on XY. Join OQ. That is your construction. Now we have to start the proof. Earlier, before I started this theorem 4.1, I wrote something, shortest distance theorem, that we are going to use over here. Let us imagine XY is a line, O is a point outside the circle. So OP and OQ are joined on the line. According to theorem, what you will get, that OQ is greater than OP. What it is? OQ is greater than OP. Okay. And what else the shortest theorem says that? That means OP is the, whichever point you take on the XY, whatever the line you draw on XY, all the other lines leaving OP, okay, they are greater than OP. So OP became the shortest distance. If OP is the shortest distance, according to shortest distance theorem, the shortest distance is always perpendicular. So what it is? Perpendicular to XY. So we got our proof. So what we are going to show that? OQ greater than OP. OQ greater than OP. Because O is a point outside the line XY, and according to shortest distance theorem, OP is the shortest distance and it is perpendicular to x, y. So now what we have written, O is that. So let us consider xy is a line and O is outside the line xy. Then according to we are applying the shortest distance theorem. According to shortest distance theorem, OP, because we have written OQ is less than OP, means OP is the shortest distance and it is perpendicular to xy. Hence, it can be proved that OP perpendicular to xy, and this is what we wanted to prove. So once again I will explain you this theorem. What is the statement of the theorem? The tangent. So xy is a tangent at any point of a circle. So the point is P over here, perpendicular to the radius. And to this point of contact from O we are going to join a line, and this line is called as radius through the point of contact. So P is the point of contact. So we have to prove OP is perpendicular to xy. For that we need given. What is given? O is the center of the circle. So you can see O is the center of the circle. XY is the tangent at P. So XY is a tangent at P. OP is the radius. This much it is given in a diagram. What we have to prove? OP is perpendicular to xy. We cannot prove with the diagram which is given. So we need to do construction. What is the construction we are going to do? Q is a point outside the circle on xy and join OQ. What does it prove? That looking at the diagram, OQ is greater than OP. Because O is a point outside the line xy. Forget the circle. We are going to take O is a point outside the line xy. And according to shortest distance theorem, OP is the shortest distance and it is perpendicular to xy. Hence, it can be proved that OP is perpendicular to xy. This is very important theorem because on this theorem only sums will be calculated. So you have to remember this theorem. What the theorem says? The tangent at any point of a circle is perpendicular to the radius through the point of contact. So this is a very important theorem. So learn this theorem, go to this theorem, see what is the diagram, write down what is the given to prove, construction and prove. So these steps are there. So without construction this theorem cannot be proved. So this is theorem 4.1. Now we will see the sums exercise 4.1 based on the theorem what we saw. Okay. What is the first theorem says, or first sum says that how many tangents can a circle have? Very important. How many tangents can be drawn to a circle? I told you we can draw innumerable of secants. When all these secants move towards the right side or left side or up and down, they all become as tangent. For example, if I take this is a circle. Okay, so 1 tangent, 2 tangent, 3 tangent, 4 tangent, 5 tangent, 6. You can draw as many tangents as you want for this what to call it as circle. So what does the first question ask? How many tangents? How many tangents? Very important. Can a circle have? So what is the answer? Infinite number of tangents. So how many tangents a circle can have? A circle can have infinite number of tangents. Then second question is fill up the blanks. Very important. What is the second question? Second question is fill up the blanks. What is the fill up the blanks says in the first question? A. Tangent to a tangent to a circle intersects. A tangent to a circle intersects it in dash point. Dash point. So we know that a tangent to a circle. What is the tangent definition? A line drawn to a circle such that it touches the circle at one and only one point. So intersects at how much point? Only 1 point. The answer is 1 point, not points. 1 point. What is the second question asked? A line intersecting. A line intersecting. A line intersecting a circle in 2 points. As the last video I have explained regarding this. A straight line intersects a circle at 2 distinct points. 2 points is called a. What is called a? Secant. So what is the answer? Answer is secant. Okay. Third question. What is the third question says? A circle can have a circle can have dash parallel tangents at the most. What does it mean? Let us see. Now, this is a circle over here. If I draw one tangent touching this circle, I want parallel. Okay, parallel means what? When can I draw parallel? The line should be opposite side. So if I draw the tangent on left hand side, I have to take the line on the right hand side. That means what it is? You can draw 2 parallel tangents at the most, not more than that. If I draw the tangent over it won't become parallel, it will intersect. If I draw a tangent over it also won't become parallel, it will intersect. But if I rub this tangent and rub this tangent, take the tangent above the circle and below the circle, then how many pair you can draw? You can draw 2 tangents at a time which can become parallel to each other. So a circle can have 2 parallel tangents at the most, not more than that. Then next we will go to the next fill up the blanks. What is the next fill up the blanks asked? The common point of a contact. The common point of a contact. The common point of a tangent. Very important. Common point of a tangent. I told you tangent touches the circle at one and only one point. That point is a common point where a tangent and a circle touches. So the common point of a tangent to the circle is called. What is that point called? Just now only few minutes back I explained you, showing. So what is that point is called as? Point of contact. So what it is called as? Point of contact. So the point which touches the circle, the point of the tangent which touches the circle, it becomes a common point, and that common point is called as point of contact. So this 4, what to call it as fill up the blanks are there. First question, you see how many tangents can a circle have? I told you it can have innumerable, because only one point, and I told you what is circle made up of? Set of points. For all these points a tangent can be drawn, so it is infinite number of tangents. Second question is fill up the blanks. What is asked? A tangent to circle intersect it dash point, only one point, single point. A line intersecting a circle in 2 distinct points is called as a secant. A circle can have at the most how many parallel tangents? 2 parallel tangents. The common point of a tangent to the circle is called as point of circle. So this is the first question and second question. Now I will start the third question. Sum number 3. A tangent PQ at point P of a circle of radius 5 cm meets a line through center O at a point Q, so that OQ is equal to 12 cm. Length PQ is, this is an MCQ question. The options are given: 12 cm, 13 cm, 8.5 cm and 109 cm. What does the sum says there? PQ is the tangent. At point P, it touches the circle. From the center to the point of contact OP, and just now only we saw the theorem that radius and tangent are always perpendicular to each other. So OP is perpendicular to PQ, so we will mark the 90 degree. So from O, the end of the tangent Q is the end of the tangent, OQ is joined. Its length is given 12 cm, this length is given 5 cm, find PQ. We can use Pythagoras Theorem now? Yes, we can use. Because angle OPQ is 90 degree for us. Because OP and PQ, that is the radius and tangent, are perpendicular to each other. So angle OPQ is equal to 90 degree. So what will happen according to Pythagoras Theorem? OQ square is equal to OP square plus PQ square. So what is PQ square is equal to OQ square minus OP square. So solution. So what is the solution first? What we will show that OP perpendicular to PQ. Reason. This reason only should be written. Radius and tangent of a circle are perpendicular. Now we will take in triangle OPQ, angle OPQ is equal to 90 degree. So using Pythagoras Theorem, OQ square is equal to OP square plus PQ square. We have to find out what is PQ. So we will take PQ square is equal to hypotenuse square minus the given side square. So what we will get? PQ square is equal to, what is OQ given? 12. 12 the whole square minus OP. What is OP given? 5. 5 the whole square. So 12 the whole square is 144 minus 5 the square is 25. So 144 minus 25. 14 minus 5 is 9. 3 minus 2 is 1. 1. So we will get PQ square is equal to 119. PQ is equal to root of 119 centimeter. Is there a? Yes. The D option is the correct answer. So option D, root 119 centimeter. This is your answer. So here always remember radius and tangent of a circle are perpendicular to each other. So we have to use Pythagoras Theorem. See how very similarity to Pythagoras Theorem are useful. So we have to use Pythagoras Theorem. In Pythagoras Theorem we have to show which is a 90 degree. So what we have to write down first? OP is perpendicular to PQ. What is the reason? The theorem. What the theorem says? Radius and tangent of a circle are perpendicular. So in triangle OPQ we got angle OPQ is equal to 90 degree. So which is the hypotenuse, OQ is the hypotenuse. So OQ square is equal to OP square plus PQ square. You have to find out what is the length of PQ. Therefore, options is given. And what option will be right? So I have to find out PQ square. So I will keep PQ square. So what will happen? OP square will come on the left hand side, which will become minus OP square. So OQ square minus OP square. Now we will substitute the value. What is OQ value? 12. So 12 square minus what is OP value? 5 square. 12 square is 144. 5 square is 25. If I subtract, I get 119. So PQ square is equal to 119. PQ is equal to root of 119 centimeter. So in this, which is the option? D option is the correct answer. So you will get the answer as root 119. We will get the answer as root 119 centimeter. So here you have to see this is the answer in the option D, root 119 centimeter. Let us see what sum number 4 says. Draw a circle. So you have to draw a circle and two lines parallel to a given line such that one is tangent and other is secant to the circle. So I have drawn a circle with center O. So first I will draw a tangent. Okay. If I draw it, that will become the given line. So how to draw a tangent, you know. Okay. So I am going to draw a tangent over here such that it touches the circle at one and only one point. That also I am going to show. So this is the tangent given to us. So I have taken PQ is the tangent and R is the point of contact. So this is the given line which became to you. For this given line, you have to draw. What you have to draw? Another line which becomes a secant and it should be parallel. Just now only I told you what is meant by secant. Secant means what? A line drawn to the circle which intersects the circle at two distinct points. So it should become parallel. So this is the another line which I am going to take. So, okay, so this is the secant and what it is touching the circle at 2 points. So this is point A and this is point B. So AB, it is a line which becomes a secant because it is touching the circle at two distinct points. And how they are parallel to each other. This is what we have to draw over here. But you have to write it down, which is the tangent, which is the secant, and they are parallel to each other. So PQ is a tangent at R which is parallel to secant intersecting circle at points A and B. This is your answer. So once again, I'll just say in the figure AB, it is a two distinct points and line is touching. And what has happened? Always remember the secant will be part of the secant will be inside the circle. So it is called a secant, and main reason for this line being called secant is it intersects at two distinct points A and B. And here you can see this line is called as tangent because it is just touching the circle at R. This is called as tangent and both are parallel to each other, and that is what is given. PQ is a tangent. Okay, PQ is a tangent at R and which is parallel. See, you can see, can you see that they are parallel to each other in the diagram? Yes, which is parallel to a secant intersecting circle at point A and B. This is what the answer for your fourth question. So exercise 4.1 completes. The next topic is regarding number of tangents from a point on a circle and number of tangents from a point outside the circle. So I have divided into two parts. We can say that a point can be on the circle and a point can be outside the circle. If a point is there on the circle, how many tangents can you draw? And if a point is outside the circle, how many tangents you can draw? So I have taken two examples over here. See, here x is a point on the circle. So you have to draw a line which passes through the x. So PQ is the line I have drawn which passes through the x, and x becomes point of contact. So very important. So x is what? Point of contact. If point of contact is there, that means if PQ is passing through point of contact, it becomes a tangent. And where will be the point of contact? The point of contact will be always on the circle. So number of tangents from point on a circle, you can draw only one tangent. Keep this in mind. You can draw only one tangent. Here I took a point which is on the right hand side. Same another circle I have drawn, I have taken the point on the left hand side. Whether the point is right hand side, left hand side, up or down, point is on the circle means you can draw only one what you call as tangent. You can see RS is a tangent and Y is a point of contact. So here Y is a point of contact. So RS is passing through the point of contact. So RS becomes a what you call it as tangent, and only one tangent through one point of contact can be drawn. So through only one point of contact is there. So only one tangent can be drawn. So number of tangents from a point on a circle is only one tangent. Let us go to the another part. What is given? A is given outside the circle. So point A is outside the circle. So how many tangents you can draw? Two tangents you can draw, which is what? Touching the circle at B and C means B became the point of contact, C became the point of contact. So AB became one tangent and AC became the another tangent. So how many tangents you can draw? Two tangents. Very important. You can draw two tangents. Okay. Another diagram I have shown that the point, the external point is on the right hand side. If the external point is given below the circle, there also you can draw LM and LN, where M and N are the point of contacts. LM is one tangent, LN is another tangent. A question will arise, ma'am, you gave on the circle and outside the circle. What happens if the point is inside the circle? So what we are going to take, the point is inside the circle. This is center O, and let us take a point A is inside the circle. Can I draw a tangent? No. If I have to draw a line, means it should pass to the point, means you cannot draw a tangent. So keep in mind, no tangents can be drawn when the point is inside the circle. So when the point is inside the circle, no tangents. So we have taken three cases. One point is on the circle, another one point is, so point outside, point on the circle, and here point inside the circle. Very important. So three positions we have taken. One is point on the circle, point outside the circle, and point inside the circle. When a point is there on the circle, only one tangent can be drawn. When point is outside the circle, two tangents can be drawn, and point is inside the circle, no tangents can be drawn. So these are the three positions of the point on a tangent. So I will close my class today here, and tomorrow I will continue with this. One more theorem is there, and sums based on that theorem we will solve tomorrow. So bye children, and thank you children.